Hey, happy Monday. Today is December 14th and it's day 10 of Number Corner. So we are going to look at our Saturday marker, which, still has an area of 5, and we have to figure out the perimeter. Our Sunday marker, area of 5, and we can figure out the perimeter. And then today's marker, which looks like this. So I'm curious to know if any of you were able to come up with this pentomino when you guys were working to see how many you could come up with. Now, does this look anything like what we've already seen before? How about this one? Maybe I should zoom back out so we can see all of them. Have we seen this? Didn't we see this one on the first and now it's rotated? So I wonder, is this one similar to what we saw on the second? Guess we'll have to find out, but I know that we talked about the fact that there are only 12 pentominoes, and that's not including how you can rotate them, turn them, or whatever, okay? So I will update our observation chart for us so that next time it will already be updated, but just for the sake of time today, I wanted you to look at it and let's figure out our perimeter and our number of sides for today's marker. Perimeter would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perimeter of 12, just like we started with a perimeter of 12 up here. And then the number of sides we have are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 sides. Okay, we do have parallel lines, we do have perpendicular lines, which we will always have when we have a shape that is a square, because a perpendicular line is going to create that 90-degree angle. And we're going to talk more about perpendicular lines today. The next thing I wanted to talk about very quickly is we did not do our calendar collector on Friday of last week, so we missed a day, but that's okay because we already passed 2000. Today I would like to update it, so I'm just going to go ahead and put that we are on day 10, so we didn't do it for day 9. That's okay. Let's roll and see what we get. Are we going to play for more, or are we going to play for less? Go ahead and toss all my numbers. 3, 4, and 8, and we're playing for more, so we're going to make the number 843. We had 3, we had 4, we had 8. We're making the number 843. Go ahead and work that out. What are you going to get if you add 843 to 2,181? All right, so I'm going to chunk it and I'm going to work it out kind of like what I would do in my head. I have 800 plus 100 is 2,981, plus I have 40, and so that's actually going to put me into the 3,000s. So now I have 3,021. Y'all see that? Because 8 tens plus 4 tens gives me 12 tens, which is really 120. So I now don't have 800, I have 920, essentially. So my 800 added to my 100 was 900, but now I need to add another 100, which is 3,000, and then I have 20 left over. So 3,021 plus 3 is 3,024. Is that what you got? So we really beat our calendar collector this month, which is another reason why I'm like, if we don't get to it every day, that's okay, just for the sake of time. All right, one thing we are going to do today, and you guys are actually going to have time to work this out on your own, because this is kind of a hard conversation to have virtually, is we're going to talk about solving some problems involving parallel and perpendicular sides. Okay, so I'm going to talk you through some of these, but then some of it you're going to have to figure out on your own. And a major part of today is justification. making sure that you can justify your thinking by coming up with things that would not be right to prove those things that you think or know are correct. So, which of the following shapes have parallel sides? What do we know about parallel sides? Right, they run in the same direction. They never, ever, ever, ever cross. So with that in mind, which one of these would have parallel sides? Do we know what this shape is called? Yes, it is a parallelogram. And a parallelogram means you have two pairs of parallel sides. So we know for a fact that this has parallel sides. The question is, what about the other shapes? And so that's when you guys are going to work independently to figure it out. But not just figure it out, but justify it. Here is an example. Look at this shape right here. What is this? You can call it an oval. Right? Does it have parallel sides? No way. How do we justify it? An oval has curved sides, and parallel has to run in the same direction. And a curved line is always going, if you have two curved lines, eventually they're going to meet, or they're just going to form a circle. You're going to go round and round and round and round, and you'll never have parallel lines. Besides, we need it to be a line, not a curved line, a straight line. That would be my justification. So I expect for you guys to do that for this shape, which is a triangle, and for this shape, okay? One other thing I would like for you to do. So if you're telling me, yes, this is a parallelogram, prove it by showing me what sides are parallel. And if you're telling me, no, that is not a parallelogram, then I want you to try to draw a triangle that would have parallel lines if you're saying that this one doesn't. And the same with this question as well. Okay, I'm going to keep moving because you guys are going to stop this video and you're going to work on this independently. Draw a figure with exactly one set of perpendicular sides. What do we know about perpendicular? It's going to form a right angle. So I'm going to try to make it as, and that was not good, so let me try that again. Make it as straight as possible. So you might want to start off with a corner, which is a perpendicular side, and then figure out what shape you're going to create from there. And I wonder how many of them you can make, or how many different ones. So that's a challenge for you. The very last question says, here's a Venn diagram organizing shapes. Do you agree with how they organize the shapes? Why or why not? So again, that's this justification. Don't just tell me I don't agree. I need to know why you don't agree. And I want to see that in words. Before you get started, I want to remind you of a mathematical practice standard, which says, persevere in solving problems. So if you think it's hard or if it's difficult for you to justify your answer, just try. Just make the effort to do so, because I think that if you try, you can do it. Never say you can't. Say, I'm just not there yet. Add the word yet to the end of that sentence. That's that growth mindset that I love to hear and see with students who are working problems out. So you have the rest of our number corner time to work on this page, and good luck. Just remember, justification. Bye-bye.